Okay, so welcome, and this is a great talk to be giving today because it is National STEM and STEAM Day, so it's couldn't be more appropriate. So we are going to take a look a little bit at deep space exploration, and specifically looking at the new telescope that will be launched next month. So I am Tim Needles. I am a NASA Solar System Ambassador, but I'm also an author and a high school teacher. So I wear a few different hats. So my book, Steam Power, is available at the library. You can take a look at it. We'll look a little bit at some of how it references space and STEAM. Space is such a big part of STEAM, of course. But some other things I do, I also have a TED Talk on creativity that you could reference as well. You can find that online. And I work with a number of different community groups, including National Geographic. So in my book, one of the people that is featured is Melody Yashar, who works at NASA Ames and Search Plus. And she is one of the winners of the NASA 3D printed habitat challenge. So she actually created the Mars Ice House. So the idea was to actually 3D print a habitat out of ice to actually send a vehicle there that would actually drill down and melt the existing ice and then reprint it and create a habitat. And the actual design is beautiful. I mean, like, it looks like a place you might want to spend time. And the idea is that the ice would actually also help shield solar radiation. So it lets light in, but it shields the radiation, which is kind of amazing. And we actually have a guest here from Ames, which is kind of amazing. So that's even cooler that we get to mention that. So today we're just going to be talking a little bit about space, but before we do that, it's kind of important to understand some of the history. So when we're talking about, just looking out to the night sky, of course, many different cultures were, tracking the phases of the moon, and you can find that historically. The original telescopes were invented by, the first person to have a patent was Lippershey, and then Galileo, of course, is probably the more well-known person for creating a telescope. And then once we started doing that, it was only a matter of time. There's a number of different types of telescopes that were developed. But one of the questions that I often get, just to put it out there first, is why do we have telescopes in space? So the most important and obvious reason is that you avoid cloud cover, and there's something called twinkling, which is when you're looking at a distant body, you notice that it twinkles like a star, and that's the color and movement is distortion. But of course, the other thing is that light pollution is a major factor. We live on Long Island, so we all understand light pollution. If you look out tonight at the night sky, you can actually see Venus pretty clearly, which is amazing. Yeah, it's kind of nice. But generally, we can't see too much here on Long Island. There are a couple of telescopes you can see at Stony Brook University and Montauk and some places. But the Earth's atmosphere also limits the ability to observe different frequency ranges, which is really important. A lot of the telescopes in space are in different frequencies, namely gamma ray, X-ray, ultraviolet, visible, infrared, microwave, and radio, right? So a lot of the space telescopes have numerous different technology to read a few different types of wavelengths, but that's the main reason we have space telescopes. But really, a picture is worth 1,000 words, and it's images like this that really tell the story better. So this is the same image with visible light and infrared light. This is from the Hubble Telescope, and it's a really well-known image. You can see some of the same points to make it clear, but you see how different the images actually look. And one of the things to understand too is these telescopes actually don't shoot in color, so it's not a traditional photograph. They're put together, and all the data gets sent to Earth, and they're actually put together here. So we'll go over how that works in more detail But it is pretty amazing to see some of these images. And the Hubble has been there doing such an amazing job for so long. It's really exciting that we have the James Webb Telescope coming. So the first question is, how do we photograph deep space? So like if we're on Earth, photograph, whoops. So when we're talking about photographing space from here, so on Earth, you're going to think about your aperture. Anyone that knows cameras, aperture is the part that opens, like our eye is our aperture, right? So you could have, you need to have at night, obviously, a really wide open aperture, but the problem is you get noise. So noise is the longer you have the aperture open, you get like these distortions, these little dots that you have to then filter out. And a similar thing happens in space. One of the really interesting things about the new James Webb is that it uses micro shutters. So it has shutters that actually work really fast, and it has numerous different shutters. So I have a few images that we'll look at how that works. But you could actually take pretty amazing images here. You know, if you could find a dark enough spot, if you go out towards the Hamptons and try to actually photograph space, you can get some really interesting results. So one of the things is you have the aperture open, and then obviously the Earth is moving, right? So, you know, one of the things that, depending on the type of image you're trying to take, you know, some people actually get star trails. You're actually able to see the stars move, and you actually are seeing the planet move over time. So it's kind of really interesting. So when you're talking about photographing in space, it's similar but different. So there's some things that are the same and some things that are different. So it does have an aperture, it does open and allow light in, but there are numerous different filters, and all of these filters are picking up different elements, and then all of that data is sent to Earth, and scientists here are putting it all together. So similar, but you know, a little bit different. And one of the things you should know is that there actually is no color. So all of the data that's sent here is all black and white, and the color is put in afterwards. And if we were to actually look out and actually try to see, you know, some of these distant galaxies that are being photographed, it wouldn't seem as colorful. So you know, they're colored as if you're closer to them. So the color should be accurate-ish, you know what I mean? But like, it's not going to be entirely accurate because it's added later. So each one of those filters is filtering a color, and you're able to actually compress that and put it all together. So that really helps. So that's a little bit how it works. And there's been numerous different space telescopes over time, even from, you know, there's some versions of them in the early 60s. So, and, you know, in these different wavelengths, and some of the notable ones, like a lot of Hubble images are actually attributed to Hubble, but they're not actually the Hubble Space Telescope. They're other telescopes. So Chandra is one that is an X-ray telescope that's still functioning and out there and sending out images. So it's actually, I believe, the most powerful X-ray telescope.
Is it still working? Is it still working?
Well, sort of, yeah. Like it's currently in safe mode. I think October, the late October 24th and 25th.
Yes, it is.
Yeah. So well, and they do have plans to actually. It is supposed to last longer. You know, NASA typically over-engineers. So things that are meant to last. You know, a great example is the Mars rover and the helicopter. Right, the helicopter was expected to last a month. You know, and it did 14 missions and it's still going. So
either they don't work or they go beyond that.
Yeah, sometimes, yeah. So it's kind of interesting, yeah. So Hubble is still working. They're functioning, like I checked even today, and they're actually communicating with it and trying to see what's sent it into safety.
Who's the main contract
For Hubble?
Yeah. Now Hubble I know is Hubble I know was Lockheed.
Yeah, I believe so.
Who's it for this one?
For the James Webb, I forgot. I have it on the slide. I'll check
Lockheed was there.
if it comes back. Yeah.
The main contract.
Right. Yeah, I know. Like I've been working with National the Jet Propulsion Lab. Yeah, it's interesting to see some of what's happening now. I mean, one of the things I'm most excited about is, you know, I mentioned the Mars rover and the Mars helicopter. So one of the upcoming missions is we're sending it to Titan, one of the moons of Jupiter. So it's a quadcopter, which is really more than a quadcopter, but we're going to have a drone on the planet. Oh, cool. Thank you.
I had another one that said go cross over the asteroids.
Yeah, it should be really interesting. Okay, so we talked about these pictures. Yeah, and we were talking about photographing here on Earth, and I mentioned noise. So this is star travel. So this is an example of that kind of image. So you can take this kind of picture here, yeah, and keep the aperture open. So you have to leave it open on a tripod for a long time, but they are amazing pictures to take, especially if you happen to go out to the Hamptons where it's dark enough, or even the Greenbelt Trail or something like that. You can take kind of amazing images and get the star trails.
Is there a small observatory in South Pole or something like that?
I believe there is, yeah.
Small, yeah, there is. I don't know who owns it. It's a small
Yeah.
observatory, 60 years small telescope.
Yeah. Yeah, my cousin works at one, and it does one in Southampton and Montauk, right? It's over in that area.
Going out there.
So like with something like the Hubble, like I mentioned, the color is a factor, right? So that you're not actually, the colors being added later. That's just important to understand. So we'll talk a little bit about the Hubble before we move on to the new telescope. But again, it is currently in safe mode. It launched in 1990. So, it's really known for the kind of amazing images we've seen. 30 years, it racked up more than 175,000 trips around our planet, which is kind of extraordinary. So 4.4 billion miles and nearly 164 terabytes of data. And they do have an amazing website where you can see some of this. This is one of the most famous images from the Hubble, known as the Cosmic Reef. So it's these kind of images that are kind of wondrous, and they've really gone into, beyond even space enthusiasts. And you see these images. I just saw them on pants the other day. So like it's that kind of thing where it's pretty extraordinary. So here's a little closer look at the Hubble. The optical cameras have the digital CCD, and they take the grayscale pictures. But it has actually become more productive now than really ever, because it has been so notable. A lot of these servicing missions add things and repair things. So the most recent one was 2009, and there are others planned. So these are some of the other recent major space telescopes. Kepler is one that's kind of notable. A lot of the Kepler pictures were actually, in talking to people that worked for Kepler, they were always proud when people mistook those images as Hubble images. So a lot of the pictures people think are the Hubble, and they're actually Kepler. Three of these are the main four, or were the main four for many years with the Hubble. So let's talk about the James Webb. So again, if you don't know who James Webb is, he was the second administrator of NASA, and he had a big impact on the Apollo missions. And this is scheduled currently for December 18th from French New Guinea. And this is expected to be the new flagship telescope. So there's a couple of important developments. One is the sun shields, right? So like that is the big silver piece on the bottom. There's a number of layers with special material that will be able to shield the telescope from the sun. You can see it kind of in motion on the skiff. So that's really important. Again, even though it's larger than the Hubble, it's also more lightweight. So the optics are much lighter. And one of the coolest things is how they kind of reference origami to fold it up and fit it into the rocket. So I love this. One of the things that I found about NASA most interesting, I started as an artist and I always had an interest in space. And then I learned that NASA actually hired artists to be creative technicians to find interesting ways to come up with solutions. So, they are folding this up to fit into the rocket, and it's going to open up over time, over the course of about a month. And it should be really interesting. So it also has micro shutters, like I mentioned, and improved detectors, of course. It's been many years, so the technology is going to be much further. And we're really looking at the history of the universe, from the Big Bang on. That's one of the main goals of all of these missions to sort of understand everything in a better sense.
The bad things is they can't repair it.
Well, it's in deep space, so yeah, that would be really, really difficult. Yeah, so you're really crossing your fingers hard.
That was just why there were delays for me, that a hard time getting this thing to fold out. That was delaying it for the trouble they had.
So the origami, and it does, the mirrors will be able to fold for different things as well. But yeah, that's the thing. It's going, so this is going much deeper space than Hubble. Hubble is, low Earth orbit, and this is going much, much deeper. So that'll be a big difference as well.
Now they want to change the name of it, I heard.
Well, there was some talk about that, but NASA is really sticking with James Webb. What? I don't believe so. It's going to be, it's at a fixed point.
So it's on orbit about a million miles away from Earth.
I think it's
just circle the Earth like
right. Yeah, it's well out of our orbit.
That's where the problem is. They can't repair it if everything was wrong.
Yeah, so you really have, we're all hoping.
Sure that it works fine.
Yeah. So there are 4 main instruments, and the main infrared camera is the NIRCam, and one of the things is that this will actually complement the Hubble. So like, it's actually going to be able to take what the Hubble has seen, and then actually, so we can pinpoint these areas we've been looking at and then have much more clarity on them. So that's going to be one of the initial really big moments. So here's a little look at kind of the point that we're at. So minus 55 days is where it's traveled to French New Guinea, and then so it's set right now for December 18th launch. And you can see like a lot of the launch elements are similar to launches you may have seen. And that should be pretty similar. But here's kind of the more exciting part to me is the actual unfolding sequence that happens out in space. So really interesting. You can see that this whole process takes about a month. So, the solar shield starts to open first. That's really important, obviously, because, the radiation and heat. So you can see that it opens up slowly over time with each piece kind of opening over the month. And then it has a 6-month commissioning period, because a lot of the testing and stuff that needs to happen before we actually start using it as a normal telescope. I think it's an Atlas rocket.
Well, Atlas rocket is American.
Yeah.
The Atlas 5
right. Does it have? I think it said. Yeah. Right.
They're paid for that.
Right.
But I don't know if it's bigger than the Atlas 5.
It's one of. I think it's one of the largest.
The Atlas 5 is the biggest.
Yeah.
Especially for
right.
Like spy satellites.
And I mentioned the Perseverance. One of the exciting things is that we're actually sending things to photograph other planets and actually explore. I don't know how many of you have seen some of Perseverance images. And, it has its own Twitter page. It has its own Instagram page. You can watch these. It's kind of fascinating. And, this has a number of different cameras on board. And it's been really fun to sort of, see some of the discoveries that it's already making. And, recently an article came out about one of the rovers actually identifying an organic compound that we don't know what it is, right? Which is exciting because that's something new. So again, like this is taking soil samples that are getting put into the tubes, which we will recover and be able to get a better sense of some of the science. And I also mentioned the Ingenuity Helicopter. So this is kind of fascinating. I don't know how familiar you are with Mars's atmosphere, but it's nothing like Earth. It's very, very thin. As a matter of fact, one of the problems that we're facing now is because it lasted longer than expected, the season changed, and it's actually even a little thinner than normal. So you have to actually, recently the rotors have to go really, really fast to be able to get the lift. So they actually had to rotate them faster than they've even tested on Earth to see if they can get lift now in this new atmosphere. So it's kind of fascinating to see what's happening. The first flight was on April 19th, and that was the first powered flight on another planet. So this kind of thing is really exciting. I don't know how many people have, tried drones or things like that locally, but it's kind of fascinating to actually be able to send these to other planets and kind of get that bird's eye view. And it's going to be even more exciting in the future. So there's a lot of plans for this. So a couple things to just know. This is really, really light, about 4 pounds. So you need something really light in order to be able to, you can't have that much drag or else you wouldn't be able to get the lift. And it flies on its own. So it's programmed and then it makes the flight. So that's the other problem. It's not like you can control it from here because of the amount of time the data takes to get to the planet. So here's a little look at some of the images. You can see the video. So pretty interesting to be able to actually see it flying over the planet.
These grabbing samples, isn't that rover grabbing samples for when they want to try to return to Earth?
Yeah, the rover's grabbing sample. Yeah, the helicopter's really an experiment. Yeah.
The rover's grabbing the samples.
Yeah.
They want to, when they try to transport back to Earth.
Exactly, yeah. So that's the idea. There's a bunch of sample tubes that they've been drilling. And then this is an example of what I mentioned about going to Saturn. So this is the Dragonfly. This is basically a drone. It's a quadcopter. So currently it's planned on launching in 2026 and reaching the moon in 2034. So I hope we're all here to see that. That's really interesting. Yeah, so like this is they call it a quadcopter. It's not really a quadcopter because there's 8. So it's an octocopter would be more accurate. But yeah, so like this is the first time that it's actually going to be bringing the science experiments to different places. So actually, it's almost like having the rover combined with the drone. So really exciting. It gives you an idea of like what the future holds. Kind of really interesting to see what we're going to see with this kind of thing in the future. So it's going to be the first time we're actually moving the payload in a copter. So I'll take questions in a second. I wanted to throw the first question out there, which is one I get often, which is which is the furthest view we have photographed? And this is the example, the galaxy GN-Z11, which is 400 million years after the Big Bang. So that is 13.4 billion years ago. That is 134 nanillion kilometers. I believe I'm saying that right. So that is 134 followed by 30 zeros. So that is how far away it is. Yeah, so unbelievable. And the exciting thing about the James Webb is that, you know, the top image is the Hubble image, and the bottom image is clearer, and this is what they believe. So the James Webb is the bottom image, and the top image is the Hubble. So they do believe we're going to have a lot more clarity for these really distant objects. So very exciting, and there's a lot that we'll see over time happen here. So it's not going to really let us see further at this point, but we are developing, of course, things that will let us see further.
You can't see because of the universe.
Yeah, and nature of how light works, and yeah, exactly. Yeah. There are limits, yeah. But it's really exciting to be able to have closer images. So also here's a bunch of resources for places to go. NASA has amazing resources for some of these things. See, these are some of the ones I use. NASA at Home is great. If you haven't seen it before, they have podcasts and videos, things like that you can actually explore. It's National STEM Day and STEAM Day, so I wanted to make sure I mentioned NASA STEM engagement and some of the things for the James Webb Telescope. So James Webb is already sort of like a superstar in the space world, so there's a lot of material on there that's really, really interesting. Cool, so that is the presentation. I wanted to leave some time for questions. I always like to end by saying, be kind, be creative, and change the world. Of course, I want to make sure I credit the images are all from NASA and the ESA. Yes. Oh, sure, no problem. Sure. Of course, yeah, no, it's a pleasure to be here. It's great to see such a large audience. I don't legally work for NASA. I'm a solar system ambassador. They're very specific. Yeah. Yeah. So I'm not. Yeah. Yeah, he does. Yeah. Yeah. So yeah, I'm a solar system ambassador. So yeah, there's a group. But you know, I have a friend that was a solar system ambassador that just went to space. So I'm really excited. My friend, Dr. Pryor. I don't know if you saw it. She was one of the 4 astronauts that went to space on Elon Musk's recent rocket. So it was really cool. She's an educator and an artist like myself, and then she actually went to space, and it changed her life dramatically, obviously. So really exciting.
You know what I say? I was watching all this. I don't think you can do manned missions to Mars and beyond about nuclear power there. It's just too long. It's just too long. It's going to take years without that. They said they could do it a round trip in 7.5 months with these new nuclear rockets.
I did see some of the information about that, which is kind of really interesting. I mean, Mars is the next real step. I think, I mean, in our lifetime, it's very possible we see missions to Mars like that. Yeah, and the nuclear powered. Yeah. Well, a lot of the space telescopes were nuclear powered as well, and you know, even those run out of energy. So it's,
yeah.
Yeah, right. No, yeah, right.
That's Pioneer and Viking. You know, they're not the propulsion system.
Right. Yeah.
Not the propulsion. They were developing almost everything. They were developing that other thing, another kind of system where it builds up strength, ion propulsion.
Oh yeah.
But they're going to go to Mars. They said they could do the whole trip, about 3 months out there, 30 days on the surface, and 3 months back.
Which is
the new nuclear rocket.
Fairly fascinating that that's possible. I know. Yeah. It's
the nuclear rocket. Not with chemical rockets.
Right. The current propulsion system would take much more long. That was one of the things that we're always facing, is how long it took to get to Mars using the current system. Right. They were worried about like the state of the astronauts, you know, like you literally being in a rocket for that long.
One system I was reading could do it in 45 days if they built it.
Oh, really? I didn't see that. That's interesting.
They're making these advanced nuclear rockets.
Right. Yeah. Yeah, it's going to be really interesting. I'm excited. There's a lot going on with space, which is kind of interesting. I grew up, you know, in the 80s, and like, you know, I got my first telescope, and, you know, there were some things happening. And in the 90s, you saw the Hubble. So like, it's so exciting now to see so much happening.
I remember when I was a kid, I remember when John Glenn went.
Oh, yeah, the Apollos. Yeah, that's cool.
That was
yeah. Oh, okay, yeah.
John Glenn and I shopping.
Yeah.
Yuri Gagarin, he was the
Yeah, of course. Yeah, Yuri's. Yeah, as a matter of fact, there's a really cool celebration of Yuri. They have Yuri's Day every year with all different space themed events. That's really terrific. If you haven't seen it before, definitely try that. It's online, and they have it in person. Yeah,
they were taking a big chance. You know, when they went up on top of spots.
It's amazing. Yeah,
even they blow themselves to smithereens. They were just lucky they never lost anybody doing that.
I think there was just recently an interview with one of the astronauts about, you know, some of the fears that they had, you know, with the first mission to the moon.
Redstones and first the Apollo, and then you use redstones and these dots. I remember this one.
Right.
I don't remember. I'm not old enough. I can't remember what's the other one. Sputnik did that.
Right.
I just remember the first man answer.
Right.
And as I said, they used these redstone. I think they used the redstone for the suborbital.
Yeah, and you know, it's also like notable that a lot of those early pieces were built here by Grumman, right? So like, if you look at, you know, I went to I don't know how many people have been to the National Air and Space Museum, but they have a pretty amazing collection there. And it's nice to see some things that were actually developed here on Long Island. Yeah, and even some of the pieces of the rover.
Yeah, it was all sometimes like
Yeah.
Rockwell built the one that orbited and Grumman built the Apollo lander.
Right. Yeah. And right. Exactly. Yeah. So, any other questions? Oh yeah, that's a good question. Yeah. Okay. Yeah. Cool. Oh, you didn't get to see them.
As soon as we landed, somebody said, "Oh, yesterday they were here."
It's got to be the wall display. They're not there all the time.
Yeah. So, you know, every once in a while we do get them here. I mean, like you can. Yeah, you catch just the edge of in New York sometimes. Yeah.
We went out on some water in a boat, and when the captain of the boat was telling us, you know what, you can take pictures now. You'll see streams of light in your camera. That's when you show the aperture before. And
right.
Think of that.
Yeah, they're right.
We didn't see nothing with our eyes, but when we got home.
You saw that stream? Oh, that's interesting. That's really fascinating. Yeah. Right, because well, also it's like where it is. So, you know, it's dark enough there, and the light is, you know, bright enough. One of the things that's interesting, if anyone, like I flew to China one time, so you go over the top of the Earth. It's the fastest way to get there. So, you know, you're literally up higher in the atmosphere than typically a plane would go. So you're getting to kind of get this view of like the curvature of the Earth, which is fascinating. Yeah. Yeah. So it's, yeah, like those kind of things are really interesting when you actually could see it.
There's got to be sunspots. You don't always see the right. There's got to be sunspots.
Yeah, those flares. Yeah. Yeah. Oh yeah. Yeah. So my first book was Steam Power, which was published by ISTE, which is Society of Technology Education. So the idea is, you know, as a creative person, I always felt like creativity belongs with STEM. I think that's really important. If you look, like, there's no better example of those early Apollo missions where, like, you know, it's all about creativity. You know, they made it work that way. So yeah, so what I did is I talked to a lot of professionals, so people here at Brookhaven National Labs and people from NASA, and I talked to all of these different professionals, even people that created some of these apps and technologies, and asked them, you know, how they felt about creativity being part, along with art and design. And then I just shared some of the projects that worked the best for me to kind of work in education. So some of the projects that are really interesting to teach science. And then some of the things that are just really important for collaboration, how to collaborate with, you know, one of the things that I think really makes us all stronger is working together. So, you know, I have a bunch of different ways you can kind of collaborate on some of these projects. And, you know, Solar System Ambassadors is a group that, you know, we collaborate all the time with lots of different projects. It's really interesting. Yeah, so that's available. You can find it anywhere on Amazon or, of course, at the library. Yeah. And then I'm working on a second book that will be out soon on creativity, specifically within the sciences and technology, and how creativity plays an important role. So I did a lot of research for these books to kind of get a better idea. So it features lots of interviews and data, and it should be really fun. So I was always a lazy reader as a kid, so I tried to make it as plain spoken as possible to make it kind of fun. And I'm a big believer in storytelling. As a matter of fact, the storytelling workshop that's coming up sounds like a fun one at the library. So I think one of the best ways to sort of teach is to actually tell stories. Right? That's how you remember things, and it makes a bigger impact. So there's a lot of storytelling in the book as well.
Have you ever worked with the military space program?
No, I haven't. It's pretty interesting.
That's almost as big as NASA.
Yeah,
the largest spy satellite.
It's totally possible. Yeah, I do know people that work there, but they can't really tell me much about anything. Yeah.
Yeah.
Yeah, no, it's kind of remarkable. I know people from other branches of the military that ended up working for the Space Force.
Spy satellites, communication,
right,
navigation.
Yeah.
And those spy satellites are every bit as expensive as the space telescope.
Oh, I certainly believe that. Yeah. Yeah, well, they have incredible funding. You know, it's the military, obviously. Yeah. Well, it's become such a big part of the world today, right? Because of all of these different countries. I believe it's possible they spend more. Yeah, for sure. Yeah, I have no idea. Yeah.
Those satellites could see an ant walking on the ground for 1,000 miles in space.
Yeah.
Can you tell us anything about Artemis?
Oh yeah, it's super fascinating. Here, actually, I should pull something up. Okay, so yeah, so this is another really exciting thing.
Artemis is actually NASA's target.
Yeah. So yeah, and
I don't know if they're going to be able to do it.
There's a number. Yeah, because I was watching closely which astronauts might get picked for Artemis. It's really exciting to go back to the moon. You know, obviously really exciting time. I don't know how much people have followed, but we haven't been to the moon in a very long time. There's a couple of fascinating documentaries about the people that have been to the moon, but this is really exciting. I know I have shared.
Yeah, I think they're all close to all dead now.
Yeah, there's only
I know what to say.
there's a few people that are.
It's almost 50 years.
Yeah, there's a couple people that there was an interview recently with someone that was on the moon. Yeah, so yeah, this is exciting, and there's a few different Artemis missions planned to go back to the moon.
Said an unmanned one around soon, aren't they? This next year, an unmanned flight.
Yeah, I'm excited about the manned mission. That's the really, and I think we'll most likely see our first woman to be landing on the moon, and that's kind of really exciting. Yeah. 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 Oh, that's cool. I actually didn't know. That's cool. Yeah.
Child, but yeah.
Yeah.
Don't forget the last Apollo flight was December 72.
Isn't that crazy? Yeah.
I remember that,
Yeah. Yeah.
But you don't remember Apollo, you know what happened in Apollo 7, don't you?
Which
They had a fire.
oh, the fire on the yeah, that was
that was
yeah.
January 67.
Right.
What happened was they were using pure oxygen.
Right. Yeah.
In capsules.
Yeah.
Ignited. Like 2 or 3 of the astronauts.
Right. Yeah. That was a
Then they mixed it. They
tragedy. Yeah.
They do it after that.
Yeah. And any of the kind of errors there's errors that happen pretty regularly, and then they'll adjust for them. Right.
Can you talk a little bit about your experience becoming a NASA ambassador?
Yeah. Sure. Yeah, that's a good question. Yeah. So like, there's all different types of NASA ambassadors. Basically, you just need to be really interested and willing to share your knowledge with people. I have friends that are NASA ambassadors who really just have telescope parties and actually just, are purely into astronomy, and other people are, into 3D printing, and they make models of some of these. As a matter of fact, if you take a look at even like the James Webb, in the resources, there's a lot of models that you could make of some of these telescopes. There's a paper model and origami and things like that. So really, it's just anyone that's interested. I do, you could certainly reach out to the library or me, or you could just search for the NASA Solar System Ambassadors. There are about maybe, I think there's 3 of us here in Suffolk. One of them is my cousin. So, and I will say that I didn't know he was a Solar System Ambassador when I applied, and then I found out there because I knew we weren't that close. And now we work together all the time, which is fantastic. He works at the Montauk Library and does programs there, so we collaborate. And of course, there's a terrific museum also in Nassau County that they have a few ambassadors that work there. And they have some great programs. They have a few astronauts that have come there and done things. Yeah, so really interesting. So if you are interested, definitely you could find it with a quick search. And there's a program to apply. And it's really all about this sort of kind of event where you're able to share and talk about space. And
so set for landing 3 years from now? They were supposed to land like in
for Artemis?
24, yeah.
I believe so. That was the last I checked, yeah. That's what I thought, yeah.
They were supposed to land. Well, I think they were supposed to land on. I don't know, they were supposed to land on.
I said there's a rover going to land on the south.
So,
yeah,
they want to check for water down there. There's a good rover.
We know that.
Yeah.
We're going there to do other things.
Right.
They want to put a radio telescope in there.
That's on the back. That's totally different issue.
Yeah.
This is to do resource utilization, essentially taking regular, which is the dust that's on the surface, and extracting the oxygen.
Yeah.
So you can actually make water. But that technology has many uses here on Earth too. So
right.
In fact, James Webb,
Mm-hmm.
but you were talking about it, you've heard of wavefront placing.
Mm-hmm.
That was developed because of those mirrors. The way they developed those mirrors, they had to do special, very smooth techniques. Lasers.
Yeah.
And we benefit from that.
As a matter of fact, one thing that you should look at, one of the most fascinating facts that I could find is if you look at the amount of everyday technology that we use as a result of NASA, there's a lot of, people, obviously NASA has a big budget, and people see that budget and they don't quite understand, like why are we spending so much money? But if you look at the amount of everyday technologies that we end up using because of NASA and the developments, it's remarkable. Like there's a list on the internet of all these things, and you're dealing probably every day with things that NASA develops for one reason or another, which is.
Where's the Ames Research Center? Where is that?
Yeah.
California, there's Ames, I know there's the others.
JPL is over there too, yeah.
JPL is out there, that's a Pasadena.
Yeah.
And they got one in Langley, and they got one in Ohio.
There's 10.
Yeah.
Kind of all together, that sounds.
Right.
So the camera on a chip on your phone.
Yeah, your iPhone is a good example.
I think it's NASA too, the drink.
Yeah. Oh, right, yeah, exactly, yeah. Yeah.
The Teflon, I think, was developed.
Teflon, yeah, that's right.
So there's a website, it's just called spinoff.nasa.gov.
Okay, great.
And every year it's a book that's about all the technologies that are living around you.
And it is remarkable when you look at how many technologies get developed from these
Well,
missions.
the Apollo mission, when they landed on a digital watch, you have more electronics.
Yeah, I know. Yeah, I know that the whole, yeah.
When something was wrong, the guy had to stick a pencil in there.
Yeah. Oh, I love, if you ever watch Apollo 13, it's such a fantastic movie for just the engineering that had to happen to, yeah, it was pretty fascinating.
And John Glenn almost got lost, but happened with the heat shield almost came off.
Right.
And one almost drowned, one astronaut almost drowned because the thing popped open, they got him out. It almost was a couple of close calls, because you know there's going to be. There's going to be.
Well, you know, early on in the days of NASA, especially the space race, it was just, you know, everything was happening very quickly, and yeah, so things were happening so fast.
But the first time we ever lost anybody in space was with the space shuttle, when it blew up that time. It was the first time
Right.
the United States, Russia lost people.
Right.
The parachute, the first time the United States ever lost people. Before that, the only one they lost was the Apollo 7 accident.
Right.
Then, of course, we had two screw-ups, and when the heat shield came off.
Which is, if you look at the amount of missions that went, actually the odds are very good. I mean, because space is still, you know, even my friend that went up there, Dr. Proctor, it's like, it's still a risk every time you go to space. So like, that's something they certainly understand. Yeah. Which is interesting now that you see so many like actual people starting to go to space. Like, you know, how does that change things?
Well, we saw Captain Kirk, Sir Shepard.
Yeah. Well, you know, the three different companies, you know, like they're going to different parts of space. Like, you know, my friend was literally orbiting. So that's, to me, like that's legitimate space, you know, and then some of these other missions are just kind of going up to legal space. Yeah.
We do Star Trek.
Yeah. Yeah.
That's a pot. You can't do.
Well, you never know. Yeah. You can't tell the Trekkies that.
Requirements. When you want to walk is 1,000 times. Yeah. It's 1,000 times the speed of light.
Yeah.
What do you think is energy? We'll think about wormholes and
yeah.
about this. Still, that's a tremendous amount of energy.
Yeah. Well, that's the fun part about science fiction. You don't have to worry about making it work. Yeah. Any other questions, Bernard? Yeah. Oh, cool. Oh, yeah, sure. Actually, some of the first beings in space were animals. Yeah, so like Lycos is notable. Yeah. So yeah, dogs, chimpanzees. Yeah.
These dogs in the United States use chimpanzees before they set the ham was one of the famous ones.
Yeah. And I believe there's an experiment. Yeah.
Specifically, we want animals like worms, the elegant,
right.
Because they've generated these studies.
Right.
See how these animals use their DNA changes.
Right, you're able to see because they change over so quick. Yeah, I think ISS always has a couple different. Right. Yeah.
Yeah. Before they sent the Mercury astronauts, they sent several missions with chimpanzees.
Right.
Yeah.
As a matter of fact, like if you remember, like Lycos was a search engine for a long time that had the image of the dog, and that's where the dog came from. Yeah. Yeah. So really interesting. Yeah. And for kids, there's a couple of new children's books that just came out on space that are pretty fantastic because, you know, kids are so much more knowledgeable about these subjects. Like I've talked to kids that know, you know, as much as I do about some of these missions, and it's kind of remarkable. Like they're kind of amazing. So it's so great to kind of see that they're actually getting so much more information. I'm doing a presentation similar to this, like, you know, I'm going to change some of it for like the Girl Scouts next week. So, yeah. It's nice. Yeah.
Where's NASA opinion on what the Navy is saying in their flight?
Yeah.
These things flying around. Did NASA got an opinion on that?
Yeah, I'm not sure. Like, you know, I know that recently there's some things that came out about it, but I don't know that they've commented.
Yeah, there's something flying around out. They don't know what it is.
I think the U.S. military's commented on it, but not the NASA. Yeah.
They were saying, you know, the Navy pilots were seeing things fly around.
Yeah. Well, you know, UFOs have always sort of been.
They go 20 times the speed of sound and slow down. He said there's something even in the military, there's something going on.
Yeah, I don't think NASA has formally commented on that though. I think the U.S. Other military stuff. That's what I thought.
You know, if this has been going on for so long, why are pictures so long?
Yeah, that's a good question. Yeah.
Better truth.
Yeah.
You know, what I want to say is thank you, Tim. This was great.
Oh, thank you.
I really appreciate having people like you come and talk about space. For the young people, NASA needs new people. Yeah. And so if you really want to be a scientist or engineer, that's great. But we hire artists, we hire education people, we hire educators, and so programmers. And so there's huge opportunities
But they do aeronautic work, so they work on airplane design.
So the big thing now is that NASA's trying to make the orbit commercialized. And so in your lifetime, when you go outside of the world, most likely you will go up into space as we work for
That's going to cost a lot of money.
So there's a huge opportunity for engineering and science. There's a huge opportunity on this everything in space. So grab it.
Yeah, that was one of the most fascinating things is all these different kinds of jobs that exist at NASA. So like I have friends that like, you know, were always interested and they didn't think it was possible. And then when you see kind of like the full breadth of what NASA does, it's pretty remarkable. Yeah. Yeah, right, exactly.
One reason we need chefs, we can't have drones in space. So we have to actually come up with
right. Yeah.
You remember Space Flag, don't you?
Oh yeah, sure. Yeah, yeah.
That was a big.
Yeah.
The first real big space station that they had.
Yeah, I suppose there's pieces of the Space Lab that are in the museum. Yeah, Skyline, right. Yeah, that's in the Air and Space Museum. Yeah.
I remember that one.
Yeah.
They almost lost it. What happened was it got damaged on the way up. They had to go up there and repair it.
Right.
They got that damaged when they launched it on a side of flight. Something happened, the panel got ripped and it was overheating, so they had to go up the actual set up for a Patchogue.
Right. All right. Well, thank you guys so much and enjoy your cups. It was a pleasure being here.